before I got in this classroom.
Yeah, I just pushed right now. So
It doesn't say that there's anything.
it doesn't. Did you hit pull? That'll change it. Did it update it at all?
Did for me.
Let me just take something.
It should say updated lesson 4 material added in class activity. No? Yeah. Seems to be a perennial problem. So, just in case, I will put it on slide.
Okay, it showed up. Just took a minute for me, I don't know.
Okay. So today, we're going to go over a few things, actually. We're going to review variables and types and values. We're going to go over control flow. So two different mechanisms of control flow. If statements and loops, and amongst that, two different kinds of loops. And then we're going to go over this notion of an optional, which is a very peculiar way that Swift uses to describe the lack of a value when you have a variable. We'll go over them briefly, but we'll go over them in more depth later when they actually become relevant. They become extremely relevant when we start going over objects and classes, which start to encapsulate common behavior and start to represent stuff like user interface. And then we're going to learn how to write simple functions, and functions that accept parameters and functions that return values specifically. So this actually starts to form the meat of your understanding of coding in general. Angel is here. We're saved.
So the first two are from last time, right?
They're from last time. Okay. So, and looking at some of the material in more depth yesterday, it looks like that functions are going to have to span a couple of classes, just to make sure that we go over everything in adequate depth. But it shouldn't be a problem because when we go over objects, we can split that up. It might mean, however, that what would normally be the assignment for week 2 will have to be due like an extra week out, just because that assignment actually involves a lot of linking of user interface to code, which essentially accelerates you and puts you into the realm of building real apps. Which is really awesome, but also a little daunting. We're going to get through as much as we can today, and hopefully leverage a different technique which will expose you to how these mechanisms work in a much more interactive way. So let's do it. Okay. So again, objective, the same objectives up here. Review lesson. So what I want to do is open up a playground and have you watch me do a couple of simple operations using variables and types. And then I'll give you an assignment to do on your own very briefly. I think you can do it individually, but you can do it in pairs if you like. So what that looks like. Sorry. This is the problem with the digital world is I have both my notes and what I want to show you together. you want to, you can open up your own playground and follow along. But I think it's more important for you to just watch. So this is primarily a review for those of you who might be a little shaky on some of these concepts, but I want to make sure that we all have the same foundation for how to use variables and types, because it does form the foundation for everything else that we do, as does setting font sizes. Okay. So again, playgrounds. Code on the lines of code on the left, results on the right. So just as a quick review, arithmetic types, integers and doubles. Integers and doubles can mix well when they're written as what we call literals. So you're actually writing out a number like you would normally see on a calculator. But when you actually start applying variables, things can look a little bit dicey. So what I'm going to do is I'm going to go through a brief exercise in calculating, or is a series of steps that one might use to calculate a monthly budget. Just to show you how, just to get you used to looking at variables and the thought process behind it. So in a monthly budget, we have what two things would normally go into a budget?
Right. Revenue and expenses.
Revenue and expenses, right. So, or income and expenses. So what I'm going to do is start with a variable, income per year. How rich do we want to be? 45 per year. You might be able to live in Manhattan for that. No? Yeah, probably not.
One more zero.
I'm sorry, yeah, one more zero maybe. Fair enough. So, so this is a variable. What's its type? Megan, what's its type?
What do you say that again?
What's the type of that income per year this variable is? What's its type?
Constant?
Nope. Close. You're in the right ballpark. So remember, variables hold values of a particular type. So what's the value here?
45,000?
That's right. The value is 45,000. Sean, what's the type?
Integer.
An integer. Do you see where that comes from?
Oh, I thought you were asking what do I type next? And I was like,
Oh,
it can't be variable because
no.
you already did
That is going to form a common point of misunderstanding for the rest of the course. Like, what are we typing?
Yeah.
What's the type? Typed variables, typed code, code that I typed. Like, it's going to be really,
Okay.
like, you are not alone. Okay. So the next is I put income per year here, but I'm interested in a monthly budget. So in a very verbose way, I'm going to create a constant for myself. It's months per year. How many months in a year? Okay, 12. All right, I want to ask you stupid questions. And so as I start to work down here, I might want to think that the first place to start getting my income together is to say income per month, which I would get by saying income per year divided by months per year. And the playground is kind enough to show me what the result of that calculation is at the outset. All right, some other expenses, maybe rent. So since they're expenses, I'm going to put them as negative numbers, just good accounting practice, I guess.
Does that work for?
No, it doesn't, unfortunately. But what would parentheses do here? Anybody have a guess? So what parentheses might do? If I wrapped this in parentheses, can't do that. Actually, nothing at all. So as far as Swift is concerned, just wrapping stuff in parentheses is kind of I was about to say no-op. Some of it, like it's an identity operation. It doesn't really do anything. What it does help us do is start to craft order of operations. When we start to look at arithmetic Some other expenses, electric bill. My electric bill is 80 to 100 a month because I keep all my devices on all the time. Phone bill. Who has an outrageous cell phone bill here?
300.
How much?
300.
Did you say 300?
I have like my husband on there.
Oh, okay. Well, that makes sense. He does all the texting.
That's just
too,
me.
obviously. And then I'm going to put student loans in here. Just for us. Sorry.
Yeah, I said, yeah, that's relevant.
Yeah, it's totally relevant, I think. And then I'm going to put in general monthly expenses. So monthly burn is, I'm going to put in food and stuff. What, $500 for food, entertainment, just lump everything together. All right. So if I want to get a sense for where I am, if I'm making money or losing money, anybody have any ideas what expression I could write to using these variables to figure that out? I think you have an idea.
So,
Nope. All right. I'll write it out in a verbose way. I'm just going to take income per month and just add rent to it. And then add the electric bill to it. And then add the cell phone bill.
Oh, yeah, I thought there was some function.
I know. No, nothing special.
I can
Nothing
add
special.
that.
That's it. All right. Yes. All right. At least we're on the same page there. Student loans. What's monthly burn? What's that? So that's my level. So is that everything? Yes, sir. What's missing in this calculation? Do you think? If I were actually to do a budget like this? Like something fundamental that we have to deal with every day. Taxes. Anybody know what tax bracket this person would be in? So tax rate equals, like, and thinking about Social Security and everything else they take out. 24? No, 35. I think.
That's fine.
Okay, 24. So what I'm going to do is change this around a bit and say that income per year actually depends on salary. Anyone tell me what I did wrong before I click on the red dot? Any guesses? Think about types. I'm sorry.
Tax rate's a double.
Tax rate's a double. That's right. But I'm dealing the entire time with
Integers.
integers. So Swift is starting to complain because when we're in variable land, Swift is really strict about whether we can use integers or doubles. It actually complains a lot, loudly, sometimes violently. Binary operator star cannot be applied to operands of ins and double. So you see how do you see how I got to the error there, clicking on the little red dot? Remember that from last time? Okay. What can I do to resolve this? Ned, what can I do to resolve this situation? Sorry. No? Okay. I'm dealing with integers and doubles at the same time. Any idea?
Change salary to a double.
That's right. By doing what? 0.0. So now salary is a double, and then it all comes all the way down here. So again,
Months.
I'm sorry,
Months per year.
months per year. Same problem. Same problem most likely. So I should change this to a double as well. And it crashes. Again, the expression was too complex to be solved in a reasonable time. Consider breaking up the expression into. That's awesome.
Can you just do?
Sometimes Swift is on the ball. Yep.
I don't know if this makes a difference. Can't you just, because rather than change every number to double, can't you just make the variable tax rate like 24 divided by 100?
24.
Divided by 100? Does that or?
What it does, anybody have any idea of what would happen if I did 24 divided by 100? What's the phenomenon that we encountered with integers before that makes that, yeah, truncation. So if I do 24 divided by 100, let me comment this out for just a second. Look, it's 0. It actually doesn't even give me the time of day to even try to do any work. It probably just looks at those numbers and says, fuck it, 0. It might not even calculate anything. No, it does. But nevertheless, integers become fraught with problems. However, this might actually work. Okay. So one possibility is indeed to change all of these to add a 0.0 on all of them, and I'll have all doubles. Another way is so here's the larger point that you hit on, which is a very good point, is that I have two techniques I can do. I can choose to do all of these calculations as doubles and add 0.0 to everything, or the question is there a way I can manipulate this calculation such that I can use integers and still get to a reasonable answer? So I'm going to do that to show you how I might change this around. But then I want you to figure out why that is troublesome. Okay? Why it's a problematic thing to do in general. We've already said the answer, by the way, but it should be interesting to see if you can catch it. So if I were to rewrite this, what I would think about doing is doing exactly what Sean suggested. I'm going to change the tax rate to 24. Then I'm in the land of hundreds, correct? So instead of, if tax rate is 24, then I probably want to start thinking about changing 1.0 to 100. Because it's not really 24 I'm interested in. It's 100 minus 24. I'm interested in the balance. I'm interested in my take-home pay, not the amount of tax that I'm sending to the government. So in that sense, I could probably take this calculation here and divide it by 100. So this puts me back in the percentage land, because the definition of percent is for every 100. And now I get this calculation. So if I work my way down here, now my leftover is slightly less than before. Okay. Why might this be a problematic thing to do? Any ideas?
When you input tax rate.
When I input tax rate, expound on that.
If you input numbers of integer as 0.24, then you will not know what to do.
That's right. That's the phenomenon that we just saw before. I have a workaround here. I'm starting to use integers instead of floats. But let me ask it a different way. Why did this particular set of code work out so well, do you think?
Only works with integers.
Sorry? I'm using integers, but what about the nature of those integers? Yes?
I was going to say, because you know the code, like if someone else tried to look at it, and they would just naturally change tax rate to a percent or to a double.
Yes. As far as collaboration goes, that's indeed certainly possible. If I don't have anything that indicates what the input should be in terms of its value, then you could totally run into problems. And it's not really natural to start talking about tax rates in terms of whole integers out of 100, but
Oh, I know.
you know,
45,000 divided is exactly with the months per year.
that's exactly right. It's dependent on the numbers that I picked, right? 45,000 is a nice round number. 45,000 is divisible by what? 10, 100, 15, 5, 3. It's like it can be divided by so many numbers. I can probably break that down really easily. If I chose a number that was, say, much smaller, or something that was not a multiple of 100, I could encounter what phenomenon? Truncation. That's right. And I could start losing values that would potentially be super important, especially during tax season, especially when the IRS is trying to find just those, subtle little errors to put you in the pool of random selected, audit candidates. So, really, okay, we have one right here, ladies and gentlemen. All right. So again, so you have to be aware not only of the types that you're using for variables, whether you're in integer land or double land, but also what are the nature of the values that you're using, because sometimes that will inform what the proper type is that you start using. It's very evident in terms of numerics because we have so many choices. We have integers and floats and everything, and it's sometimes a toss-up between the two. It can also become a little confusing later when you start using objects, which are essentially, or classes rather, which are essentially custom types. Okay, so what I'm going to do very quickly is rewrite this in terms of floats. And so what that means is I'm going to change all of my constants to floats by adding 0.0 on the end of it. I'm going to change tax rate back to something that's probably more natural in terms of what I normally think of a tax rate being. And now I'm going to put this, 1.0 minus tax rate. You notice I get the same answer down here. However, when I click the eyeball, it tells me it's a float, at least in my version of Playground. All right. Does this exercise make sense? Defining variables that contain values of a particular type? Yes?
So, doesn't this mean that when you're thinking of user data that's coming into your app, would you always need to be turning it into a double?
Not necessarily. Depends a lot on what the nature of the data is, but it also depends a lot on the rest of your code. So if you're using libraries, and those libraries say, give me an integer, then you're going to want to, give it an integer, kind of thing. So it becomes much more contextually dependent in those cases, at least in my experience.
Can you limit the possibilities on the keyboard that will show on the iPhone to be only integers, so you cannot type dot something?
Yes, you can.
Okay.
Depending on exactly what kind of interaction you want, it can be easier or harder. But yeah. Okay. Yes, sir.
I just wanted to say something based on what you were saying there. One thing to keep in mind also, as you said, when taking you to an input, is that in a situation where there was an input box and you were taking salary and someone would put an integer, it would be fine. Not anymore, actually.
Rent.
So for rent, if they put in, for example, 800, that would be an integer coming into this code. But someone might put 850. 850 cents, right? So in that situation, you're taking in an input as a double, and you would have to do some extra work to make it work with this code, which is processing.
Excellent point. Then it becomes this dance of managing user input and code. And you're going to start discovering that managing user input becomes one of the biggest kind of, I want to say pain points. It's kind of a strong word to say, but it's one of the biggest pain points in building an app. It's like trying to think of all the different ways a user can put something into an input box and then trying to decide what to do. If you're accepting a salary and someone starts typing in their name instead, what do you tell them? Did you detect it early? Did your app crash because they put a string in instead of a float, etc., and so on? If you're accepting a salary and they put a dollar sign in it, and you didn't expect them to put a dollar sign in it, you expected them just to type numbers, etc., etc. And one technique is to attempt to limit their ability to put certain types of characters in, certain types of input. But what if it was amongst other fields and you wanted to keep a consistent keyboard experience? Like, it starts to become these trade-offs when you start to think about app design and then the code that powers that UI right now. This line, line number 13, months per year. What's different about this line, Allison? It's a constant. It's exactly right. Why would I have chosen to make this a constant instead of using a variable? It's your turn.
Why did you make it a constant?
Yeah, why would I have made it a constant?
Because it's not changing. Once per year, it's not changing.
That's right, it's never going to change, ever. Ever, unless we adopt a different calendar somehow, sometime, like the Roman Empire, changing calendars all the time. Okay, so this is an example of when I would use a constant. It's kind of a it's kind of a cheap way of showing you how constants differ from variables, but the assumption is that these variables could change at some point, perhaps due to user input. There are other variables up here that I could justify using a constant for, ones that don't necessarily represent input, like income per month, perhaps, or income per year. And I might consider doing that just because it's strictly computed from two other variables that represent user input, but the fact that I'm dividing would never ever change. And so this actually doesn't change the logic of the code if I start changing my salary. So at least with this app, I could probably decide what salary I could accept and still keep my head above water, but nevertheless. Yes?
Okay, so that begs the question, if you're never reassigning a value to a variable, isn't it essentially a constant?
Yes.
Okay, so what benefit do you have on setting something constant versus a variable?
What do I?
Like what's the what's like
What's the-
outside of, just explicitly stating it?
Right.
Unless you are reassigning the value, every variable is a constant, essentially.
Yep.
Okay.
Yes, indeed.
Okay, all right.
If you're not going to change it, it's a constant. There are some situations, some syntax that require us to use a constant instead of a variable that are coming. There are other situations where constants are more natural to use.
Okay.
But if it never changes, it's in your advantage to use a constant. You do get some performance boost out of it, but in my experience, it has never been palpable to the user. So, sorry, have you?
Yeah, I just wanted to add one thing. So also keep in mind that when it comes to Swift, what Apple is trying to do is to really push what's considered the right way to code, or safety. If you're the only one working on this application, then you have a certain mindset and things just make sense.
Sure.
But if you were to take this block of code and give it to somebody else, by you saying that this is a constant, that other developer cannot change this
So
value.
best practice.
Yes.
It's great.
And you can assume you can make variables depend on other variables, right? So like if salary goes above a certain place, the tax variable would also
Yeah, it could
you
also
can put
update
you
as
can put
well.
like functions within that.
I could make this an entire function that would traverse, that would use some equation from the
Yeah.
IRS.
So it's not always just like a manual input. It's
That's correct.
okay.
Okay, so I want you all to give this a try with a playground that you start. So start a playground. And what we're going to do is a unit conversion exercise. It's going to be super simple, but I want to get your fingers typing var and let and learning the difference between them. So open up a new playground in Xcode. Just go to File, New Playground. Name it whatever, anything that you want. Lesson 4, unit conversions.
Do you want us to put this in whatever folder and submit?
You can put it in the exercises folder under lesson 4. I'm not sure that I created one, however.
No, there wasn't. It's fine.
There wasn't? Okay. So let me create that. Oops. So what we're going to do is simple, is a series of unit conversions from metric to imperial. Why not? Anybody know how many feet there are in a meter? No. I know you know.
Everyone but Constantine.
Right. Everyone but Constantine. Anybody know? Go ahead and Google it. Doesn't matter. Anybody know? So we get it first.
3.28.
3.28. Okay. You answered your question. Now, someone tell me a statement that I might use to set a variable that would represent that very value. Anybody have an idea of what a meaningful variable name or constant name would be? Any guesses? Ned? Any guesses? Well, it's the number of feet in a meter is 3.28. So how would I express that in code? Megan, do you have an idea?
Feet per meters equals 3.28, or let feet per meter.
Aha. Let feet per meter equal 3.28. Why did you say let?
Because it's never going to change.
This is never going to change. Okay, so, all right, how many feet are there in a football field? Or the length of a football field in feet? 300. How would I represent that as a variable here, or a constant? And you're up. You're still up.
Football field length.
Okay. Like this? 0.0. That can work. We know we're working with doubles, but what's missing from this statement? Let. Why did you say let? It's fixed. It's not going to change. All right. How do I complete my goal? How do I complete my goal? What am I going to try to do, Sean? What's the next step?
Well, what are you trying to get to?
That's a great question. What are we trying to get to? What is it that we're trying to get to? So, sorry.
How many feet? How many meters?
Meters in a football field. That sounds like something we could. That sounds like something we could compute. How would you compute how many meters are in a football field? Or, excuse me, the length of a football field in meters? Just got your brain. You have an answer?
Print.
No, wait. Hold on.
Sorry, I thought you were pointing at me.
No. Well, I will soon.
Okay.
You have an answer?
Oh, you divide 300 by 3.28.
That's right. How would I do it using the variables? Just tell me what to type.
You said variables.
Oh, excellent catch. What should I have said? Right. What should I have said instead?
Variable.
Yeah, they appear to be variables, but they're not. They are constants, exactly. So that computation you just gave me, 300 divided by 3.28, I think we're all agreed that that's correct. But how would I do it using the constant names? Just tell me what to type.
Football field length divided by feet per meter.
Sounds right. What's extraneous here? What did I not need to complete that calculation?
The let.
I'm sorry?
The let.
The let. Exactly right. So if I remove this, now I just get a straight up answer. 91.46 meters. Is that right? Okay. Okay, excellent. Simple enough.
Can I ask a question? Would
Absolutely.
it be wrong if you wrote print line in front?
Absolutely not. In fact, I encourage you to do so. I encourage you to do so like this. Because what that starts to do is put you in a mindset of writing code that you're then able to embed into an app. right? With the naked expression, Philadelphia length slash feet per meter is not going to work when you're writing code in a .swift file. It just will complain. So you actually need to give it this function in order to tell it to do something with that value. And that something is print that value to the console. We haven't seen that in action yet in Xcode, but we will soon. Okay. So does this workflow make sense to everyone? How we write constants, how we write variables, and so on and so forth. Okay. What I think we're going to do is go on to the next stage of material, which is actually to start to talk about this mysterious thing called control flow. So we're actually going to introduce you to very simple programs today. So far we've been doing unit conversions, simple calculations with variables, but what I want to do is to introduce this concept to you and start to show you the different constructs and their corollary syntaxes that enable you to write them. So this notion of control flow, remember when I told you that code is executed from top down in a single file? Control flow is this notion that enables you to start to control that sequencing of steps. Just like you're executing a recipe, and you come to that point in the recipe where it says, if you want nuts in your brownies, add almonds, or whatever it is, or add walnuts. The walnuts are optional, at least for me, like, they're disgusting. They should never end up in brownies. But as far as a recipe is concerned, you want a recipe to be able to support, in some cases, more than one state of brownie. So in a programming sense, programs are executed one line at a time in general, but it's not always useful to execute all of those lines at all times. And so we're about to encounter this construct that is called a conditional statement. So a statement that's executed only if a certain set of conditions is met. And those conditions are very logical, very mathematical, and typically very deterministic. And the type of reasoning we want to support are things like this. If the temperature is less than a certain amount, 32 degrees, then show an icon that indicates freezing. Otherwise, show a regular water icon. So if we were designing a weather app, we might have logic like this that starts to show different types of icons based on what the current temperature is, or the projected temperature, or whatnot. So the second type of control flow that we're going to go over today are loops. This is a way that you can start to take what would normally be large chunks of logic and compress them down in an automated way. So you can start to tell Swift, this line of code, like, call this line of code 100 times, or keep calling this set of code until a certain condition is met. That sort of thing. So anyway, what I want to do is show you interactively how that works. So in this case, let's say I am designing a weather app, and I actually want to start talking about the world in terms of water and its states of matter. Maybe a weather app isn't the right thing. Maybe I'm writing an app about basic chemicals and states of matter, because typically the weather doesn't get to 212 degrees. So I'm going to define a variable. Let temp equals 16. Let's assume that that's in Fahrenheit. Sorry, but if it's in Fahrenheit, the freezing point of water is 32 degrees. So I'm going to write a simple Boolean expression that returns whether this is less than 32 or not. So anybody have an idea what that simple Boolean expression might be? Idea? Good ones. Sorry. Less than. I'm sorry. No, just say what you're going to say. Say it.
Less than or equal
Yes.
to the products.
That's right. So what should I type?
Oh.
Yeah. So you got the right operator. So less than or equal to, right? Because 32 degrees is freezing. It's not technically true because of how enthalpy works, but we'll think of it. We'll consider it true right now. But you got the right operator. But what's the actual code that I want to write? So this is stage one in learning how to program. Well, I found the right concept, less than or equal to. But you actually have to be able to convert that into a meaningful statement to actually get Swift to compute it for you. So what do you think that should be?
10 less than or equal to 32.
That's right. True. Is 16 less than 32? Because according to Flonase, 6 is greater than 1. If you've seen that commercial. No? I hate that commercial so much. Right? We attack 6 causes of allergens in your face, and 6 is greater than 1. Thank you for that fact. In any case, if you remember from last class, less than or equal to is written as a less than sign and equal sign. It's an operator. It's a binary, what we call a binary operator. So it's a symbol that takes the value to its left, takes the value to its right, called operands, and does some calculation to it. So in this case, it takes an integer on the left and an integer on the right, and returns a Boolean value. It computes to a Boolean value rather. If that condition is met, if the value on the left is less than or equal to the value on the right. Does that make sense? So even though this is 16, this is 32, the whole thing together equals true. Now, the syntax that I'm about to show you leverages the fact that this says true. What I want to be able to do is to say something like this. If this statement is true, then do something about it. So the way that we express that fact in Swift is like this. If temp is less than or equal to 32, I'm going to put an open brace, and I'm going to say print line freezing. And the playground is kind enough to print freezing. It's one of the things I don't like about the playground is I can't scroll up unless I. Okay.
I'm sorry, what's the reason for the bracketing?
I'm sorry?
What's the reason for the spacing? The bracket there.
Oh, like the way that I've written it like this?
Yeah.
Okay, so this is completely by convention so far. So those braces, we're going to call them braces or curly braces. You might see some literature that calls them brackets. Completely wrong. These are braces. Yeah. But you'll see brackets every so often. They're wrong, and it's important because there are brackets, and there are different kinds of brackets. So we're going to call these braces. The braces and any lines of code that show up in between them is called a block. It can be multiple lines within them. But in this case, because Swift is white space agnostic, I could write this on one line, but I encourage you not to. I encourage you never do it. It's just easier to stick to convention, and it's much more readable. So this is valid.
Don't do it.
But please don't do it. Don't do it. It's much harder to read. It's easy enough to type this as well. It's just a couple of returns. You're not saving yourself anything by doing it. And you'll notice that this block of code is indented by 4 spaces. So the convention in Swift is spaces. It's 4 spaces for every indentation. But what this does is it starts to offset that block of code to tell you that it's not always going, that it's what we call nested under this if statement. Okay? So in this case, we can start to associate this part of the expression, this part of the if statement rather, of the conditional, to this block. So I'm going to use these terms interchangeably. I'm going to sometimes say conditional statement, but that equals if statement, which equals if else statement, etc. So all of these are going to be synonymous. So if you hear me use these terms, they all mean the same thing. Which did you use? Was there any
You
convention?
didn't stick to any. Oh, you mean the block?
As far as the names go, can
No.
you say you didn't stick to one term?
No.
Okay. I'm trying to balance consistency with thoroughness and ease of speaking. All right. Temp is 16. Anybody have any ideas as to what might happen if I changed temp to 40? Sorry? Nothing? Nothing would happen? Nothing at all would happen.
It wouldn't write freezing.
It wouldn't write freezing. Oh, okay. I know, I'm picking on you as far as relativism goes. But in this case, if I think about the code executing from top down again, one step at a time, temp is 40. The value of temp less than or equal to 32 changed to false because that statement is no longer evaluates to true because 40 is actually greater than 32. And therefore, this line of code within the block is never executed by Swift. Actually never happens in this case.
So that just says if true. Great.
That's right. And in fact, why don't we try that? If I say if true, print line and it says freezing. Okay. Sometimes it's useful to do this. Sometimes, most of the time, it's not. But what I'm going to do is to show you how to expand the statement in order to try to get some extra logic out of it. So if I wanted to have...
I have a quick question. Oh, sorry, go ahead first.
Sure. So what I'm going to do is I'm going to write a second if statement here that accounts for the case that I'm in now. What if I actually wanted to execute some code when temperature was equal to 33 or more? One way to do it would be to write another if statement. What would that if statement look like, Allison?
Sorry, what was that? If it was greater than 33, you said?
That's right. If it's greater than, if it's still, yeah, the other case, like if it's not less than or equal to 32, what statement could I write? Just tell me what to write.
If 10 greater than or equal to 32.
32.
That's not you, that's a block.
You said not freezing. Okay. Excellent. Now, from a logic perspective, what's wrong with this statement? It's perfectly valid, by the way.
Just be greater than 32.
It should just be greater than 32. Why should it just be greater than 32?
Because the other